Thank you very much. Good afternoon, everyone, and I'm glad to see those of you who came back after coffee. I was just telling them I think I got the longest title presentation in here. I don't know if I could have added a couple of more things in here, but we do want to keep to 20 minutes. Let's see. Oh yeah, my son is taking chemistry at university, so he grabbed this down for me on theory. I'm not sure whether we're in theory or in practice. We're probably more in practice than in theory, but it's something every lab goes through. Today I'm going to talk about three separate topics and try and combine them all together into one. First, I'm going to talk about CAPE Technologies and their cleanup kits. Secondly, I'm going to talk a bit about ACE. I got the wrong acronym in there. And thirdly, about a TSQ 8000. Cost of analysis. I'm in a commercial lab. Unlike our previous speakers, we've got government and university labs. I run a private lab. Our aim is to make money. That's it. But we also aim to do quality work. And we look at ways of efficiencies and ways we can improve what we're doing in the laboratory. Sample extraction is always a tough one. For waters, liquid-liquid samples, a liquid-liquid extraction and a SEP funnel, there's nothing that beats a lab tech. You get strong arms shaking your SEP funnel. Soils, tissues, typically soxolate. We do an acid digestion ourselves. They all take time. Cleanup steps, there's a number of cleanup steps. You know, Jeff ran through a few of them earlier. You can do acid and base washes. You can do acid-based silica, basic alumina, fluorosil. There's many different ways you can go at it, and I think each one of us has our own opinion as which one is best, but in some sort of combination, you're going to work through them. Fluorosil, carbon, all used in dioxin analysis. What I want to talk about is a simplified cleanup, and developed by a company called CAPE Technologies out of the United States, and it involves a tandem acid silica gel combined with carbon columns. It was originally designed for a screening method for the bioassay kits, and I believe CAPE to this day sells that service. But it's been looked at by labs like ours and other labs and adapted for use with high-resolution mass spectrometry. It's quick and cheap. You can run a dozen samples through there in 4 to 6 hours. Consumables are about $20. They are consumables. About a $500 upfront cost for the manifolds that you need to go with it. The one thing I like about it, we always would pack our own acid-based silica gel columns or straight acidic silica in the same piece of glassware day after day. It'd get washed, it'd get put back into use, get washed, put back into use. And I don't care what kind of a cleanup system you got, unless you're putting it in a 450-degree oven, you're going to get cross-contamination sooner or later. With the ACE cleanup, because it is disposable, you don't have that cross-contamination. It does separate dioxins from PCBs. Further than that, it'll separate the toxic PCBs from the rest of, or from most of the rest of them. Where this comes in handy is in North America, we tend to do a lot of 209 congener PCB analysis, unlike in Europe where it's the dioxin-like and the markers. So we needed a method where we could either put them all together as 209 or separate them into the dioxins and stuff we didn't want to run. And interesting, I'll show you some data later on from MOE Ontario where they took this same technology or this same cleanup, and they not only did dioxins PCBs, but they added PBDEs and PCNs in there as well. You can see the the glass column there, it's a 27 centimeter column, 15 millimeter ID. It's got 5 grams of acidic silica gel in it. And the bottom of it is meant to couple direct onto a little carbon column. That carbon column is packed with 150 milligrams of 2% carbon, and it's in an FEP tube. Each column is packed individually. You can see the seals top and bottom. They are airtight. So you could theoretically pack alumina. You could pack other cleanup materials in them and have them sealed so that they are airtight. Columning procedure. You can see we've got 6 columns lined up. That manifold is set for 12 columns. You load your sample, you pre-rinse with toluene, dichloromethane, hexane, and that's the carbon column you're pre-rinsing. You attach that carbon column then to the bottom of the acid silica column, and your carbon column is either beveled or flat, and that's because you need to remember whether you're in reverse flow or straightforward flow. You load your sample, 30 mils of hexane. That contains about 80% of your PCBs. You pressurize it to 10 psi, and that gives you a flow rate of 1 to 2 mils a minute. You don't want to go faster than 2 mils a minute. You don't want to go slower than 1 mil a minute because we are a commercial lab. Once your 30 mils is passed through, you remove the carbon column and you attach it to an empty column. And you attach it in the same direction that you were flowing through already. When you put it on the on the empty column, you flush 6 mils of 1-to-1 toluene hexane through there, and that will elute your dioxin-like PCBs, plus a few other PCBs. You then reverse the carbon column, put it back on, add 30 mils of toluene, elute that, and there's all your dioxins. So you've now got 3 fractions in about half an hour. Elution order for PCBs. As I said, we like to do all 209 congeners. I've just summarized some of them here for you. I don't know if you can see it too well, but what I found interesting is that the cutoffs for each of the levels of chlorination match the same patterns as you get out of an SGE-HT8 column, because that's the elution order of an SGE-HT8 column, and they just went, either they were in fraction 1 or in fraction 2. And Jack, you probably have more idea as to what's in an SGE-HT8 column than I do, and there must be some logical chemistry reason for it. But it's very clear how they cut off. And again, for the penta-CBs, once you get into the hexa and above, they're either only the dioxin likes are in F2, everything else is in F1. For those who do run 209 congener analysis on an SGE-HT8, PCB 203 can co-elute with 169, PCB 110 can co-elute with PCB 81, but with this separation, there's no longer a problem because the first 2 PCBs are in F1 and the dioxin likes are in F2. Yeah, I guess the only one it doesn't pull is the 127 out of there, but I don't know. I've never heard of anybody reporting 127, so it's not really a major problem. All the marker PCBs except PCB 28 are in F1. It's one of the unfortunate things, and I haven't tried to fix it any better than that. We typically, as I say, don't do marker PCBs, so it's not a concern for us. But for those of you who are, it means you've got to run F1 and F2 combined, or run them both fractions. Dioxins are all in F3. When we've done spike recoveries of the test, as I say, 93 to 107% with about a 12% RSD. It was a little lower for the octa and the octafuran. Again, 1613 does not use a labeled octafuran, so the correction is against the octadioxin, and that could be the problem there. We have noticed too that the cut points between F2 and F3, if you're not exacting with your 1-to-1 toluene hexane, you can get the tetrachloro or the dioxin and the tetrafuran in the F2 portion. This is some work published a few years ago by MOE, and that just shows the cut points that they had. They used a different fractionation, but they managed to split up the different groups. Once we got to that, last fall or last summer, we got an ACE in-house to try out. I've never been a fan of ACE for dioxins. I've seen too many carryover stories. But we decided Thermo wanted us to give it a try, so we did. But what we did was we used their new 100 mil dionium cells. They said you could go with 1 gram of lipid in there, no problem. And we said 1 gram of lipid is a problem. We need 5 to 10 grams of lipid in there. So that was my concern, is that it maybe wouldn't handle the increased lipid. We do a lot of fat samples for analysis, which is why we wanted the higher concentrations. We had initial problems with packing the cells. I think we spent a couple of months figuring out how to get the cells packed properly. Once we did, if you pack them too tight, you get one warning. If you pack them too loose, you get another warning. But if you pack them just right, it works. That's the simple one. I've never packed one, so, but Jose in this picture is our packer. Once he got it down, it's good. General conditions for the ACE, 100-degree oven, 1600 PSI, 5 minutes, a fairly basic program to go through. We took 5 butters, 6.25 grams of butter at 80% lipid, ran them through. I was really concerned that we'd get some carryover. We ran the butter by itself. We ran it spiked or fortified with dioxins, got good recovery. But what I was even more impressed with is after our basic cleaning of the cells, we did not, even though the level of spiking was high, we did not have any dioxins in there. For PCBs, the same thing. The control is our analysis of the butter using our traditional method of an acid digestion, and the other data is from the ACE. So butter's pretty easy to put through. I should say that all the data was cleaned up using the Cape Technologies columns. We get horse meat. It's not horse meat, it's horse fat. And of all the samples, it's the only samples we've ever had submitted to us that fail. So if you're in Canada, especially in Eastern Canada, where some parts are known to serve horse meat, don't eat it. That's my only comment. We've never had a horse meat pass, actually. But we don't have regulations in Canada. We only have guidelines. So that's a whole nother matter anyhow. Control was our standard method. We ran 5 times through the ACE. And as the concentrations were higher, the reproducibility was better. As you know, on the hexafuran at low levels, the RSD was quite a bit wider. So then they said, could we use we had just purchased a TSQ 8000. We want to put our alkylated PAH and our pesticides on the TSQ 8000. So the question came up, could we use it for dioxins? And you know, it's what, 1/3 the price of a high-res mass spec. We've got 2 DFSs in the lab. Gosh, if we can use a TSQ rather than a high-res mass spec, we can improve our throughput. But again, in North America, We don't have your enlightened view on triple quads, so it's not allowed for use on any data in North America. It's a benchtop instrument, obviously more affordable. In theory, more uptime, you know, easier maintenance and whatnot else. You know, and we're told if we can get Pat to do it, you know, we can probably teach anyone to do it. Pat's my business partner, by the way. We set it up. He set it up for, the instrument came in just at the new year. Pat was away for holidays. He worked in March to set it up, so this data is all fairly new. We started out with the standard EPA calibration down to CS low, but CS low isn't good enough, so we take 20% of a CS low, which means 20 femtograms injected. Now, you probably can't see this, but this is a 20 femtograms to 20 picograms for TCDD and TCDF. The RSD in there is less than 10% for those compounds. When you get, I think the largest RSD in here is about 12 or 13%. So certainly it has the capabilities. We said, well, we've got all these extracts that we've run through the ACE and through the column cleanup. Oh, here's a picture of our 20 femtogram and the 200 picogram standard. We've got this data. We want to take some carp that we've got, some reference material. We'll put it through the ACE. We'll run it by high-res mass spec. We'll run it by the DFS and compare the data. So we started out with 10 samples, although by the time we got to the TSQ, we were down to 7, thanks to some lucky handling in the lab. You can see there's some variability in there on some of them. But in general, when we look, the reference values are the first column. The averages are all within the reference value. I said rather than tables, I don't know whether this is better or worse than the other. The first one is for your TCDD. The first line has the range of values for the TSQ, then the range of values for the DFS, and then the certified range for the carp. In general, looks very good. Conclusions, yeah, it's got a lot of potential on the TSQ. I didn't think we'd be able to hit our low-level standard. And indeed, we didn't hit it the first time we tried. Pat had to tighten a few things up and get them going. But it shows a lot of potential. The ACE, you know, a lot of you use ACE regularly. We haven't, but I think we'll be switching all our food methodologies. I'm still not convinced that it's good for soils. I'm worried about carryover on that, but it works. And if you want an inexpensive way of running your samples, the Cape Technologies method, we use all our food, all environmental samples go through there, and we've got a really good data set on that. Thanks to Pat for getting things through. Pat likes to go to the Philippines, and every time he goes there, he likes to do something a little bit strange. So whether it's riding water buffaloes, but also it's his birthday tomorrow. So I just want to say happy birthday, Pat. That's it.
Do we have any questions for Dave?
When you showed this method with this, acid silica gel,
Yep.
and the other one, what's the amount of fat you can put on this small silica gel?
On the small column, I wouldn't put more than a couple of grams. However, there is a 25 millimeter wide column that's loaded with 50% acid silica gel, and we can put up to 10 mils of oil on there and get it through. We use that for all our oils now, and just a real quick cleanup for them.
Any other questions?
Thank you so much for this nice presentation. In your opinion, with the experience in the triple quadruple, what is the first idea that should be improved in the instrument for routine analysis? What is something is missing you working with the instrument?
Well,
I don't know. Let's say so.
You get a couple of things. Maybe Pat would be better to answer that. But we're a high-res mass spec lab. It's a different instrument. I mean, we've run lots of instruments. You know, just the training and setting it up. It's a different way to go. I forgot to say thanks to Frank Theobald for helping us set up Target Quan 3 to handle MS data, because it's not just plug it in and you're ready to go. There's always one more thing and one more thing. You know, I think the whole injection system is you know, once you get it optimized and set up, you're in good condition. The problem, or what we don't know yet, is how durable it is over time. We just haven't operated it enough. We're optimistic, but we just don't know. Okay.
Just before, Dave, you leave the stage, I think you've already preempted Pat's birthday, but I want to say a special thanks to Dave and Pat. Many of you probably don't realize we tend to use beta testers and labs to run through all of our occasional bugs. And Dave and Pat have been heavily involved in that over the last few years. Last year we gave Dave a prize and Pat complained that he didn't get one. So I'd just like to personally wish Pat happy birthday and thank him for that. So.